Hey everyone, welcome to day 23. It is the 25th of March and we are doing something a bit different from usual. Well, I did something a bit different from usual. So as you can see, there's a link to a video here. So today I pretty much spent the whole day following along with this YouTuber called Nana. They did a very good video on just Docker and the start of Docker, where you can, first watch this first and then slowly start to get more into it. So it's like a crash course for beginners, and it's just had a lot of high praise, so I figured I'll give it a go, and yeah, it was very nice. I suggest checking out their video. But anyways, I pretty much made notes of everything they said. Yeah, we won't get into the first parts because they're pretty much a repeat of what I said yesterday, just a bit more detail. If you want to read it, you can read it right here, or you can watch their videos. But we're gonna dive into this part here because this is very interesting to me. Docker images versus Docker containers. So what is the difference between the two? If you go into Docker, this is the graphical user interface. You can see there's containers and there's images. So what is the difference, right? Well, Docker image is actually a read-only template which contains all the necessities such as dependencies and configurations. So pretty much it is the application artifact, whereas the container is a running instance of an image which operates as an isolated process. So pretty much, here's an analogy for you. The Docker image is like a recipe for baking a cake, and the container is the cake which is made using that recipe. And another analogy you can think of is that you can bake multiple cakes or containers from the same image recipe. And if a cake is eaten or deleted, the container is deleted, you can always bake a new one using the recipe. That's why, as you can see here, I have a lot more containers than images, right? As an example, right? Because these are the recipes and these are all the cakes I can bake with just those two recipes, if that makes any sense. So how do we actually get these images to run containers from? Well, there are these things called Docker registries. I talked a bit about them yesterday, but not in too much depth. So here's a public Docker registry, Docker Hub. There are also private ones, but mainly I'll be using the public ones because it's just a lot easier access. So yeah, Docker hosts one of the biggest Docker registry, which is the website Docker Hub. And next we got image versioning. So this was what I was a little bit confused on yesterday, where I tried to pull straight from Docker pull CentOS and that wasn't working. That's because I didn't go down here. As you can see, supported tags and respective Docker file links. Here there's none, but if we go to something like Nginx, you can see there's a lot more. So rather than me just typing docker pull Nginx, I'll actually execute docker pull Nginx : and one of these here. So as an example, I will docker pull Nginx and 1.27.4. Pulling, yep, and then extracting pull complete. So now you can see in the back, here it is. It's just an image right now, right? No containers yet. So how do you run as a container? Docker run, right? Let's just do docker run nginx 1.27.4, and there we go. And now it's active, in use, and you can see here is a container I made. And like I said, you can make multiple containers at the same time. Here's the syntax, docker pull, which is what I used, which pulls an image from the registry. So by default, Docker pulls straight from Docker Hub, so you don't need to specify where to pull from. Now to check if it's running properly, Docker PS, that's what we covered last time. But as you can see, right now, because I'm already running it, I can see it kind of like disrupts the command line, right? As you can see, like, oh yeah, I forgot to mention the tags. Yeah, I should go deep into tags. So basically, since things are always changing, always updating, as you can see, there's so many different versions. Sometimes it might not work with your Docker version or OS, so that's why you need to specify these things called tags, right? And by default, if you run just docker pull nginx, it will pull the latest tag, like the most recent release. See here, latest. That's the latest tag. It's very special because that's the default. But actually, the best practice is to actually specify a tag like 1.27, 1.27.4. So I made a mistake of just running docker pull nginx, which pulled the latest, which wasn't really compatible with mine. So yeah. So best practice, once again, is to run a command like this, docker run image name with a tag, rather than just without. So yeah, and once again, running an image, pull here. Running an image, same thing, right? Specify the tag, and let's go back to, as you can see, I can't run any commands. Like I try to run docker ps, right? But I can't because because it's blocking the terminal, right? So now I'm forced to either make a new terminal or press Ctrl C to quit out. So now if I run docker.ps, you can see it's not running anymore. But if I run it again and I want to check if it's running or not, let's make a new one. Docker.ps, you can see it's here. Now I can get all the information on it, but I can't do it on the same terminal. So what do I do about that? Well, there's actually a very useful tag. So let's just exit out here. Instead of just using docker run nginx, we can do docker run with the tag d. This means I wrote it somewhere. Detach, yeah. It stands for detached mode. So nginx. Let's run like this. You notice that I can still keep typing. See, now it's working. But obviously it doesn't give you these logs like before. So how do I read the logs? Well, docker logs, and then you add the container ID right here. So let's just copy that. Copy those logs and then paste it here. And there you go. It'll be just as if I ran docker run by itself. Next we got port binding. So you might wonder what that is. As you can see, docker ps, you can see the port it's running on is 80. But if I go into localhost 80, nothing's there. How do I fix this? Using the option P, we can set it to something. So an example, we can set it to 9000, and the syntax docker run, we can detach it and then docker P, and then we add the new port with the current container port, which we can see is 80 right here under ports, and then the image name and tag. So for now, I'll just do first of all, you might want to stop it, right? Docker stop nginx. Oh, another thing. Let's go to, maybe it's easy to see from here. Look, as you can see, there's already 3 containers, like, and you might be wondering why. Well, every time we actually run the command docker run, we actually make a completely new container. That is, it never uses the same one, right? So yeah, as you can see, we've already use the command docker run 3 times, and so instead of running the same one 3 times, it will make a new one each time. So maybe you don't want this, right? As you can see, this one's called, they also make their own names. Reverend Wiles is the current one. If you look back, maybe it'll be something else. You can probably see here, yeah, Reverend Wiles, Nostalgic, whatever, Determined Django. So yeah, it's just hassle using docker run all the time. So instead you can do, let's just docker stop this one for now. Sorry, you need to use the there you go. Now if we run docker ps, so nothing should be here. Okay, so we wanna, let's say we wanna start again, but we don't wanna, make the same mistake. Yeah, so to see all of them that's not running, look, there's already a lot. So let's just stop some, let's remove some of them. Docker rm, let's get rid of that. Right, I can see that deleted, or you can just simply go ahead and delete it. This is a lot faster. But let's say we just want to make it once. So let's just start a new one, docker. So this time let's give it a name. We can name it, right? Instead of it giving us a random name, we can detach it and we can give it a port. So let's run that command. Docker run. Let's go web app. Detach it, give it a port of 80, Nginx. Okay, let's check it out. It should be, yep, the name is web app, it's on 80. So let's try. Yep, see, now it works. We're on Nginx. This page, the web server is successfully installed and working. Okay, let's move on. As I was saying, let's say I'm gonna stop it. Docker stop. Oh, and you might not remember the ID every time, right? So instead of the ID now, I can just use docker stop web app. And as you can see, it stopped, and then we can do the same thing with start. So start will actually start it, docker ps, and it will make a completely new, as you can see, it's just one here, same one for 8080. So this will make, using the start command is, instead of the run, will make it a lot cleaner for you. So next we move on to creating our own images, because so far we've just been pulling from public registries and whatnot. How do we actually make our own image? Which is what most companies want to do, right? After they develop an app, they want to deploy it to a server for users to use, and they want to package it on Docker. So how do we actually make our own image? Well, first of all, we need to create a definition of how to build an image from our application, and this definition will be written in a file called Dockerfile, which is a text-based document which contains all the commands to assemble an image, and then Docker will build an image through reading those instructions inside the Dockerfile file. And here's the basic format of a Docker file. So first of all, what you need to know is, Dockerfile is a Docker container is an isolated environment, and it's usually based on a lightweight Linux OS. And so Docker files always start from a parent image or base image, which you choose based on which tools you need to have. So if you're running a Node.js type, JavaScript type, you need Node, and so on and so forth. And that's why Docker files will begin with a from instruction, right? To know what parent image or base image you need. And then you have run commands, which will execute any command in a shell inside the container environment. You also need copy, which copies files or directories from the source, which is our local environment, and adds them to the file system of the container at the path, which is the container, at the path destination, which is the container. And sorry, I made some typos here. Working directory, which sets the working directory for all the following commands. And then lastly, we have a cmd command, and there should only be one cmd command, which cmd instruction per Docker file, as it defines the default command to run when the container starts. So it's usually at the very end. So as an example, after all that, after you've made your Docker file, simply run docker build with the path, and you can add some options like t or tag, which sets the name. So an example of afterwards will be docker build option t, have the name of the thing and tag, and then the path, which you can just have a full stop for. So yeah, that is my those are my notes for the video. Go check their video out. I'm sure it will be much more in depth. It's much more in depth, and actually has some diagrams to help you guys understand if you were confused on any of these parts. But yeah, thanks for watching. See you guys tomorrow.